We conducted research on the recording angle in video modeling examples. Video modeling examples are videos in which a procedural task is demonstrated, for instance, solving a Rubik's Cube or making an origami figure. There are two angles from which a video modeling example can be recorded, first person or third person. In a first person recording, the video is recorded from a viewpoint of the one who performs the task, as if we were looking through his eyes. And in a third person recording, the video is recorded from the eyes of someone else, one who observes the one who performs the task. Research has shown that observing first person recordings leads to better learning than observing third person recordings. They have called this the perspective effect, but about why this effect occurs still exists uncertainty, and we studied literature and derived two somewhat competing hypotheses. First, and this is the explanation most research seems to point towards, is the hypothesis we will call the embodied resonance hypothesis. In short, we can only perform actions from a first-person angle, so our motor memory has only first-person behavior stored in it. First-person videos thus more closely resemble actions within our motor memory, and thus receives more support from the mirror neural system. The second hypothesis is the expectation alignment hypothesis. This hypothesis suggests that individuals inherently expect to perform tasks from a first-person angle. This expectation prompts the execution of mental rotation, which are spatial transformations simulated mentally. These are quite taxing for working memory, due to which the information is less effectively stored in memory. So we created a design to distinguish between these two hypotheses. We created a task that involved an educational electrical circuit kit, and participants were tasked with replicating the configuration shown in the video. We manipulated three factors. First, the video was recorded from either a first-person angle or a third-person recording angle. Second, next to the monitor on which the participant watched the video, the physical circuit was displayed and its orientation resembled either a first-person or third-person angle, and participants were also informed that they would execute the task from this angle. So this factor was called the expected angle. Third, half of the time the circuit was rotated just before participants performed the task to create a task angle independent of the expected angle. We assessed task performance and how much cognitive load participants experienced while watching the video and how much cognitive load they experienced while doing the task. In total, 128 participants took part in the study, and there were 2 trials per participant. Through mixed design ANOVAs and mixed effect models as contrast test, we distinguished between our two hypotheses. The embodied resonance hypothesis would be supported by a main effective recording angle, where first-person recordings outperform third-person recordings. The expectation alignment hypothesis would be supported by interaction effects, where a match between the recording angle and the expected angle would outperform a mismatch. So, either both first-person or both third-person, as in both of these cases, the participant would not expect to need a mental rotation. We found that first-person recordings led to better task performance than third-person recordings, but this effect was rather small. And we also found that a match between the recording angle and the expected angle led to better performance and less cognitive load during the video, with large and moderate effect sizes respectively. In cases where there was a match between the expected angle and the recording angle, it also made a difference whether the task was also performed from that angle or not. If the task was performed from an angle that differed from these two angles, performance was still impaired and cognitive load during the task increased. Well, what does this likely mean? Participants conducted mental rotations during the video if they expected having to perform the task from a rotated angle. But if they did not expect this, they did not conduct mental transformations. But if they then had to perform the task from a rotated angle, they still needed to conduct these mental transformations, but during the task. In both cases, their performance was impaired. Overall, we found evidence for both of our hypotheses, but the evidence for the expectation alignment hypothesis has a bigger magnitude. Still, it is likely to assume that both hypotheses explain the perspective effect to a certain degree. A practical implication of the findings is that they nuance existing guidelines based on the perspective effect. You do not always need to record videos from a first-person angle. And a theoretical implication of the findings is that they tell us something about how the brain processes spatial information and how this is shaped by individuals' expectations.